Yeah, so thank you very much for coming. So today we'll be talking about the topic here, Mikrotik IP settings for performance and security. So this is a feature on Mikrotik router, especially on IP settings. So these are the settings. So basically, yeah, hopefully this is going to be a very short one, so short presentation about about the topic that discuss features on IP settings over here. Oops. Uh-oh. Oh, I cannot minimize the zoom. Okay, what should I do? Yeah, yeah. So yeah, the topic today is just only one. What's happening? Sorry, the screen is black out. Okay. So this one over here, yeah. So yeah, very simple configurations, only one page, and then we will discuss the options inside. Okay, so let's continue. This is our agenda. So we do review and then we do Mikrotik IP settings. Maybe not live practice because you already seen the pictures, and then if you have, and then we can do Q&A. Okay, introduction. So for those who are new to our organization, so we are GLC. We are doing consulting and IT training. We do Mikrotik networking, especially networking, system admin, and Linux foundation. Not foundation, Linux stuff, and then programming. Sorry. We also develop our own product like a Radius Manager, and then we do regular events like what we are doing now. So my name is Achmad. I'm based in Bandung. I do many things related to networking, sysadmin, and then programming. I have a LinkedIn account over here. Okay, so if you don't mind, we can connect through LinkedIn. Okay, so yeah, about past experience. Yeah, we do mainly related to yeah, Mikrotik, sysadmin, and then programming in several countries. Okay. Right. Yeah, about the webinar. So we invited you to be a presenter here. So some people already coming, joining our webinar as an external presenter. This is just a place for sharing experience, knowledge, information. Okay. Yeah, thank you very much for coming. So if you don't mind, you can introduce yourself here. Okay, so at least we know where you are from. And then the language that we are using on Thursday is English. Okay, so on Tuesday we use Bahasa Indonesia language, but on Thursday our language is English. Prerequisite, this is some well, this topic is not really for a newbie. At least you need to have some idea about what's going on in the network. At least we assume you already know computer network, and then you already know how to use Mikrotik router OS. Okay, let's start. So we already familiar with OC layer and protocol. So we have 7 OC layers, and then the inside layers we have protocols. Yeah. And then we have an encapsulation process, yeah, from the applications and then down to layer 4. We have a segment datagram or packets and then frame. Okay. Either we use OC model or TCP IP model. So the one that we are using currently, the stack that we are using is TCP IP. Okay. It's TCP is layer 4, IP is layer 3. So that's the stack that we are using. And then so this is an example of layer 4 header, layer 3, layer 2, layer 2 Ethernet, layer 2 Wi-Fi, or 802.11 with a variation of what is it? Technologies, yeah, 802.11a, b, g, n, ac, and whatever. Okay, so there are lots of improvement in 802.11 technologies. Okay, so as you can see, there is a big overhead when we do encapsulation. Okay. Yeah. So the more encapsulation, the more header you are using. Okay. If you put MPLS, the header will be increased. Okay. So also we know that we have addressing either layer 2 or layer 3. Okay, so with this mechanism of addressing, we should be able to send packets from source to destination, right? And then we have IP. In layer 3, we have IP established in 1981, long time ago, and we're still using it up to now. This is one technology, oldest technology that we are still using, more, I think, already 40 years already, okay, but because it's good, we're still using it. Even though there is a new generation for IP, which is IPv6, but not so many people are using it, right? So this is address layer 3 looks like. Okay, we have a network part and host part. We have a network ID and broadcast ID. We already assume you already know how to convert from binary to decimal, decimal to binary. And then we know that what's the difference between IP address, subnet mask, so that you can get the network ID and broadcast ID. You should be able to implement the AND operation between IP address and subnet mask. Okay, so here's the VLSM RFC. Okay, so we don't use anymore class A, class B, class C. Okay, because with that mechanism, we still use a class network part and host part, but a long time ago, we only have 3 choices for how we split the network, either /8, /16, /24, which class A, class B, class C, but we don't use it anymore. Why? Because it's really waste of IP address. Yeah, IP address is limited, and then if we keep using it class A, B, and C, and then the IP address already finished a long time ago. Okay, so that's why there's a RFC that, okay, we don't use class A, B, C anymore. We use VLSM, and then because we use VLSM, and then for routing, we will use CIDR, classless inter-domain routing. We have a router and routing. Okay, so router is the device to forward the packets. Routing is the process. Okay, so usually when we develop a network, we set up a physical topology, and then later on we develop the logical topology that consists of the information of layer 3. Right, so on every router, we develop a routing table, which working like a firewall. So you have to match, and then eventually you will be forwarded, the packets will be forwarded into a nearest gateway based on the destination address. Okay, so we know that, okay, so this is supposed to be here. Okay, so routing protocol is here. So this one is not correct. Sorry, I need to update the slides. Okay, no worries. I will update the slides later. Okay, so that's the place where routing table happens. And then this is the how the routing table looks like with the administrative distance. Okay, administrative distance, it depends on the routing protocol that you are using. Okay, so logically from A to B, we always use a path that has the lowest distance, right? So yeah, you want to arrive to a place as soon as possible. Regarding static routing itself, you develop the routing with the static method. So you statically set up a network, okay? It's not the network, statically set up routing. So you you configure the routing table manually, okay? So that's the keyword, okay? Routing entries is created manually. Okay, so you have to log in one by one and then create the routing table. And then we have dynamic routing. Okay, so we don't have to put the routing entries manually one by one. So we just fire up a routing protocols like RIP, OSPF, or BGP, and then they will exchange the routing table and then set up the routing automatically. Yeah, which is things that we are using in the internet. Okay. And then, yeah, because internet is a collection of network, every network has their own identifier, like AS here. So AS is identified by AS number, given by RIR, okay, EPINIC, ARIN, DRIVE, etc., etc. Yeah, so this is how you connect to the internet. Okay, so actually I think the more appropriate way for saying connect to the internet is part of the internet. So you're not connected to the internet. Okay, you are part of the internet. Okay, so because you must have your own public IP, you must have your own AS number, and then you can connect to each other, like in this diagram. Okay, so where do you get the things, the IP address and then the IS number? Well, that depends. So we have an international body, internal organization named IANA, and then IANA delegates some office authority to RIR, regional registry. And then we are here, RIR itself, we have IPNIC, RIPE, NCC, we have EFRINIC, we have LACNIC, and then we have ARIN for North America. So every organization must have IP address block to join the internet, and then they will be identified by AS number, okay? So here everyone can understand how it works, okay? And then important to note that from A to B and then from B to A, the path can be different, yeah? There's no guarantee that incoming path is similar to the outgoing path. Outbound, it's not similar to the inbound. It's not always similar to inbound, but most likely it's similar, okay? From A to B and B to A, most likely it's the same, but it's not guaranteed. Yeah, that depends on the settings on the routers. What we can control is the outbound traffic, right? Not the inbound, because the inbound is the is others routers outbound. Okay, so we just become a passive party on communication. Next is about the private IP, public IP, and NAT. Okay, so as we explained previously, so you have IP addresses, okay, connect to each other, but public IP address is very, very limited. Okay, so actually it's already been finished if we don't use this private IP. Okay, so you have a router over here. Okay, so this is your router, and then this is your interface. Okay, your interface 1, and then this is your interface of LAN, right? So, and then so you connect here the internet. Okay, so here is the public IP. Over here is the private IP. So if you want to connect from LAN to WAN, there will be a process named NAT, okay, network address translation, to translate from private IP to public IP. So that's the main purpose of NAT, okay. Any questions so far? No? Okay, so let's go to IP settings, Mikrotik IP settings. So these are the prerequisite that you need to understand. If you don't understand, please do understand, because otherwise you'll be missing here. Okay, so let's talk about Mikrotik IP settings. So yeah, IP settings is, you can see the menu, just go to IP and then IP settings. Okay, so there you can see this parameters on your Winbox. Okay, so I'm using version 7 here, but yeah, not there is no difference between IP settings on V6 and V7. Okay, so let's talk one by one. So we can see a section here. 1, 2, 3, 4, 5, 6, 7. Okay, so 7 divider. Okay, so we have 8 sections. Yeah, let's talk one by one. Okay, so first is IP forward over here. Okay. Yeah, that one is used to forward the packets. Yeah, this is, you know, Mikrotik is based on Linux, Linux kernel. And then if you are using Linux as a router, on IP tables, you need to activate these parameters, which is IP forward, okay? Oops. Okay, anybody?
Yes.
Oh, yeah, yeah. Okay. Can you hear, can you still hear my voice? Yeah.
10 seconds ago, no. But now,
Oh,
yes.
okay. All right, right. Yeah, yeah, yeah. Okay. Okay. Yeah, looks like it's getting better now. Yeah. Yeah, okay. So the first option is, this is IP forward. If you are using Linux as router, and then most likely you must activate this option, okay? So it's very straightforward, just turn it on, and then boom, your router becomes a router, so a device where it is capable for forwarding packets. Otherwise, it's not router, okay? If if it is router, and then you have to activate this one, IP forward. Right. Next is about redirect. So we have redirect here. So the redirect here is available on this one over here. Okay, so we have a send redirect, accept redirect, secure redirects. Okay, so what it means for redirection is the redirection of ICMP. So from if we are using redirect, so there is a redirect request, okay, for ICMP. So from A to B. So ICMP, for example, is ping, right? From A to B. Okay, so we have a ICMP request, and then ICMP reply. Okay, so this is initiation. This is reply. Okay, so yeah, it's pretty straightforward from A to B. Yeah, B will reply directly to A. Yeah. But in some cases, there is a request for redirect the ICMP. Okay, so normally we can just turn it on. Okay. Also fast path. Okay, so this is also important here. Okay, fast path. Okay, so this is to enable fast path feature. Okay, if it is active and then it's working, and then you can see a tick over here. Okay. Yes, so just enable this one, so it will be enabled automatically. So currently, if you already turn it on the features, but it's not active. Okay, how do I know? From this one. This is not active. So if it is active, and then there is a tick over here. Okay. What else? Route cache. Yeah, this is also good. Yeah. So as you know, we know that there is a routing table. So routing tables, right? So here's you have a destination, and then this is you have a gateway. Okay, gateway, and then from this one, gateway 1 for this destination /24/20, gateway number 2, blah blah blah, 24, gateway number 1. Yeah, so every time, so every packet coming, so packet coming to a router, so every packet we need to do a routing table lookup. Okay, so so one packet coming, routing table lookup, second packet coming, routing table lookup. Okay, and then this one is really headache. Yeah, especially if you have lots of packets coming to your router. Okay, 1,000,000 packet, 1,000 packets. Yeah, lots of packets. It would be easier, or you can save our energy if, for example, you want to go this one, and then this is the gateway. Okay, so I will use other colors. So this is, so for example, the first packet already used this destination, and then this is the gateway. And then because they already been used, the router remembers, oh, okay, so if I want to use, if I want to go to this destination, and then this is the gateway, I will put it into cache, so that next time, the next packet number 2, this is packet 1, here's packet number 2. So when packet number 2 coming goes to the same destination, and then they will just check the cache. Okay, so they don't have to do routing table lookup. So this is can improve performance. Okay. All right. So next is this one is good. It's called RP filtering, which is this one. Okay. Yeah. So this is very good because this is for security. Okay. Okay, security. Yeah, this is security features, especially when you are using router that is directly connected to the internet. Okay, so for example, this is your router. Okay, this is your LAN 192 168.0.0/24, yeah, over here. And then this one, this is LAN, and this is your WAN, right? And then this is your public IP. Okay. So this is the part, okay? So over here on the left is LAN, on the right is WAN. But /24, okay? So packets coming from here and go there. But there is an attack that is spoofing your IP address. So the packets arrive here on your WAN, but claiming it's from 192.168.0.0/24. Okay, so okay, I say it again. Packet coming from your WAN interface, okay, not LAN interface, from your WAN interface. So when we have packets, we have a destination IP, we have a source IP, correct? But here we receive here one on one interface, and then the source IP address is this one. Okay, source IP address. This is not correct, right? But it happens. Yeah, it happens. So destination is here. Okay, but source is now. Yeah. So this is why the reverse path filtering happens. Okay. So we need to do enable source validation. So if we enable the RP filter here, the router will check. Okay, what is your source source IP address? Oh, your source IP address is this one. Oh no, it should be coming from the LAN side, not one side. Okay. Do you understand? Yeah. Remember, I assume you already know the routing. Okay. So that's why we do a network review. So to make sure that you already understand what's going on. Okay. Right, so this is what happened, yeah. So reverse path filtering. So we are validating the source IP address, okay, whether it's coming from the appropriate interface or not. Okay, so you have several options here: no, strict, or loose. No means no source validation, so it means that your router can still receive this kind of attack. Yeah. Strict mode is really strict. Okay. So not only checking the IP address, but also the interface. Okay, so if you have a LAN 1, and then here you have a LAN over LAN 2. Okay, so that part also is checked. So it's very strict. Okay, so it has to be coming from this interface, right? If the router see things like this, it will drop the packets automatically. Okay. Second is loose mode. Okay, defined in this RFC. Yeah, it's the first part. So incoming packet checking. But yeah, regarding the interface, it's not really really checking. Okay, so there is no real checking for that. So this is very good for BGP. Okay. So in our BGP router, okay. Yeah, so you have a BGP router over here, for example. This is your BGP router. You have two BGP routers. Sometimes, and then this is your internal router. So, for example, this one, and then this is your LAN. Okay. Okay, so BGP1. So this is your internet. Okay, and then this is your LAN. So there is a possibility that, okay, so for outgoing, you go this way. Okay, for outgoing, this one. But for incoming, you are using different path. Okay, this one. Okay, so if you do strict here, you'll have a problem with this. Okay, so better if you use loose instead of strict. Okay, so I can see there are so many mistakes on reverse path filtering when they implement, and then some people cannot access the internet. Yes, that's what happened. Because with BGP, incoming and then outgoing traffic can be different. Okay. Any questions so far? No. Yeah, so this is good, yeah, for DDoS attacks, because sometimes DDoS attack is spoofing our IP address. Okay. So activating this RP filtering would be very helpful. Okay. Yeah, as I said, the things that I was doing here was asymmetric routing. Okay, so asymmetric routing means outgoing, outbound path and then inbound path are different. Okay. Next is TCP sync cookies. Yeah, so this is to prevent common SYN flood attack. Okay. So this one over here. Yeah. So you just activate that, and then to prevent your clients for SYN's flooding attack. So you know TCP is yeah, I think there will be a webinar in the future regarding TCP. Okay. Yeah, TCP Deep Dive. Okay. So we are learning how TCP really looks like. Okay. So because up to now, usually if you are taking CCNA and TCNA, you just know, okay, SYN TCP is reliable, UDP is not reliable, right? Blah, blah, blah. And then TCP, you have a three-way handshake, blah, 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 blah. Yeah, perhaps we can do that. Yeah, because that one requires sometimes, not sometimes, often, when you analyze, when you are working in a ISP, most likely you will be analyzing IP stream. Okay, application is application is slow, and so on and so forth. Okay, so yeah, back to the TCP. So from client to the server. Okay, so client sends a SYN. Okay, and then SYN plus ACK, terus, and then there will be SYN. Okay, ACK. I forgot the sequence. Okay, so here is the three-way handshake. Okay, so with the SYN attack, the attacker will send lots of SYN. Okay, SYN. They're sending SYN. Okay, synchronize. Why is it called synchronize? Because we want to synchronize our number. Yeah. Yeah. Okay, so yeah, for normal operation, it should be okay. Yeah, but sometimes it's very rare. And when you activate this one, some service got affected, but it's very rare. Okay. Yeah, so yeah, that's this SYN cookies. Other options is not really. Okay, so as you can see, other options is just to specify maximum entries of some parameters like neighbor entries. So you have IP neighbors. Okay, if you have if you want to display all of them, you can just define here. And then there is a ARP timeout. Okay, so ARP is address resolution protocol. It's a mapping between ARP. You have IP, and then you have MAC address. So this is layer 3. This is layer 2, right? Okay, so the mapping between layer 2 and layer 3 is ARP. Okay. And then we have ICMP rate limit. Okay, the maximum limit for ICMP. Well, I think that's all, guys. That's all for today. So yeah, hopefully you can understand those parameters on IP settings in Mikrotik, and then you can use it for your own good. Okay, so any questions? We don't have a live practice here. Any questions regarding the topics, or you can suggest a new topics for the future. Okay. Maximum neighbor entries. Yeah, maximum neighbor entries means total numbers of neighbors that can appear in your IP neighbors, right? As simple as that, right? Yeah, so I think that's all. Yeah, allowed neighbors in ARP, sorry, an ARP table. So sorry, not IP neighbors, but ARP tables. So still related to ARP here. Yeah, so this is one section, right? So here and here. So this is related to ARP, and then this is the ARP as well. Okay. So so in one segment, so one interface of router will connect to one segment, layer 2 segment, and then in the layer 2 segment there are clients, there are clients, there are computers, and then those computers will have a MAC address if they are using Ethernet. And then this parameter here, maximum neighbor entries, defines how many ARPs neighbors in ARP table. So I think I need to update the slides. Yeah, right. Okay. Yeah. I think that's all for tonight. Hopefully it looks like yeah, we don't have any live practice. Looks like nobody's asking. No questions. Q&A, yeah, if you have any questions, if you're interested, just come to our training. Just contact us through email or WhatsApp. We will reply it for you. Next week, there will be a class for MTCNA in Bandung. Okay, so yeah, let's see who can attend the class. Okay, this is end of the slides. Thank you for your attention. Okay, if you don't mind, you can submit your feedback on the link over there. Yeah, feedback. Just let us know think about the things that needs to be improved. Yeah, further events will be available on our website, Facebook as well. Slide will be available on Slideshare. This is the links. Discord is available too on in Bahasa Indonesia. Recording will be available on YouTube, but it's already streaming out live, right? Yeah. Yeah, so okay, I have a question. It controls the number of ICMP requests? No, it's not. Okay, so ICMP rate limit here, it means that the space it's limiting the rate of sending ICMP packets that match the ICMP rate mask to specific targets. Yeah, as you can see here, default is 10. Yeah, 0 is no limit. Default is 10. So the space between response in milliseconds. So it's 10 milliseconds. So not too high, not too low. Okay. And then this is ICMP that goes to the router, not to the client, right? Okay, so anything else? If no, and then I think that's all for now. So I think I need to update the slides as well, so that because some parameters here are not available in the slides. Okay, so I think that's all. Now it's time to do photo session. So if you don't mind, you can turn on your camera and then take a picture. Okay. Okay, I will count 1, 2, 3, and then I'll take a picture. Okay, 1, 2, 3. Oh, I forgot the thumbs. Okay, thumbs up. Yeah, thank you. Right. So, okay, let's do it one again. 1, 2, and 3. Yeah. 1, 2, and 3. One more. Yeah. Okay, guys, I think that's all. Thank you very much for coming. There will be next webinar for next week. I'll see you in the next webinar. Thank you very much, and then have a nice day, and then keep safe, and then have a nice good evening for everybody. Okay, goodbye, and thank you.